Good evening. Hello everyone. A warm good evening and a welcome to the resource person, all the participants in the advisors team of ThickNess Learning Community. We, ThickNess Learning Community, are happy to have you here for the international webinar on robotics and its opportunities. We, ThickNess Learning Community, is a new online startup zeroing in on sharing the knowledge through collaborative studies by organizing expertise in professional talk, inspiring and motivating young minds towards entrepreneurial leadership vision through various programs, and accelerating women empowerment that commits to the quality of their life. Our upcoming webinars are Embedded System, Python Programming, Data Science and its Opportunities, along with many more, and certified courses like 3D Printing, Robotics, Entrepreneurship, 5G Technologies, Ethical Hacking, etc. And now I will like to introduce our dynamic resource person, Mr. Anand Virudagiri. Mr. Anand is an IT professional with 15 years of experience in business intelligence and data analytics. He is currently working as a senior business intelligence consultant in Minnesota, USA. He is also the co-founder of Sparkle Computer Education. He started his career as a faculty in NIIT Chennai during 2003. Later, moved into the software industry. He has worked in data analytics department of various companies, including Standard Chartered Banks, Polaris, PepsiCo, and Mayo Clinic. Because of his continued passion in teaching, he started Sparkle Computer Education in Minnesota, USA, along with his wife during 2016. Apart from his regular job, he currently takes computer classes for kids and adults of all ages. With this note, I would like to welcome our first person, Mr. Anand Virutagiri. Welcome, sir.
Hello,
And once
Kritik.
again, we would like to welcome all the members of the Thickness Learning community for a wonderful evening. Over to the resource person.
Hello, Kritik, and hello, ThickNess Learning community. It's great to be here today, and thank you for inviting me. Yeah, I think we can just jump into the presentation for today's topic, which is robotics and its opportunities. Right. Yeah. Before we start here, a quick intro about myself and also about Sparkle Computer Education. Thank you, Kritik, for that intro that you have given. We have been doing this computer education for kids of all ages and also for adults as well, to start with basic computer education and those who are interested in programming and robotics. Now let's move on to our topic today on robotics and its opportunities. So what exactly this session is going to cover is, I have tried to make it a very simplified agenda here. So basically, I'm trying to answer three questions here: yeah, what, why, and how. So to start with, what is robotics, and why we should learn it, and how to build a career in robotics. That is what I'm trying to answer today. I hope you find this useful. So before we move on to the actual what question, let's just see how exactly we as humankind has evolved into robotics industry now. I have been reading a book called Sapiens, The Brief History of Mankind, which was written by Yuval Noah Harari. That was a very interesting book, and I would really suggest everyone to read that. So from that book, what the main things that I understand is that the human civilization, or the sapiens as we call it, started over before like 70,000 years ago, and then just it was only 12,000 years ago. Humans or Homo sapiens really started the agricultural, and that's what the author mentions as agricultural revolution. And that happened just like 12,000 years ago. When I say 12,000 years ago, it seems to be a long term, but when we compare it with the whole the time of the earth, and how the other living organisms living here, it's a very 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 smaller time. And before 12,000 years, agriculture started. That started the agricultural revolution. And then only in the last, say, 500 years, we moved on to the next revolution, which is the scientific or the industrial revolution. It started in the 1500 AD, and then things have changed dramatically after that in the last 500 years. And only in the last 100 years or so, or even less than that, is where we ended up with computer revolution, right? Electronics and scientific revolution, which takes us a leap forward again and to where we are right now. As you could see in this image, we started as Homo sapiens roaming around in the jungle, and then we moved to the industrial revolution, working as a laborer, and then creating products and stuff. And then currently I would see ourselves here on the the virtual reality age where things are going more virtual. A lot of progressions are happening in the robotics field and the electronics and computing and stuff. And the next stage of this, as per the book, the author says that there'll be an age or an era that that's actually going to combine humans with electronics. It's more like a cyborg what we see in movies and stuff. So we'll be having some implants of electronics and stuff, as you could see in this image, the last but one, where it would be a combination of humans and then some electronic stuff. And then there will be another huge revolution, which would be the robotic revolution, which is going to happen sometime down the lane. And the author actually mentions that in a multiple different ways. Again, I would strongly suggest you to read that book, to get a better idea on that one. So that is where we are now. That is where our human evolution is right now, and all the path are now moving towards the direction which is called robotics. All right, let's move on. So let's start with our first question. What is robotics? And this is a very, very simplified answer for those who are completely new to robotics and who just want to have an idea about what exactly robotics is all about. Robotics is a part of engineering and science. So it's again a part of engineering. It's not again a part of any one singular branch of engineering. That's what they would commonly say. No, it's not just specific to mechanical engineering or electrical or electronics. It's actually a combination of every other part of engineering, and there are more other branches that are involved in robotics too. So yeah, we all know that it has to do with creations and buildings of robots, and it involves a lot of computer programming as well. It is interdisciplinary, as I mentioned. It's a combination of mechanical, electrical, electronics, and other kinds of engineering too. And so why robotics? What exactly robots? There is so much to talk about that, and we may need a separate session just to talk about robots. But for this session, we will confine to robots are sometimes we use that specifically at this point. The goal is to use it where it's not very safe for humans to work with. Apart from the regular service robots, the majority of the research is currently going on is more onto this one, like finding and diffusing explosives or going into hot places, when there is a fire, and saving people, and anywhere, and even for like wherever it's distant for humans, like if sending a robot to Mars, which was already done. It's something like wherever humans can't reach, that is where we are trying to send out a robot or do a task that is very tough or it's dangerous for humans to do. So that is what robots are all about, and that is what the study of robotics and then the programming for robots, it's what we call as robotics. And when it comes to the word robot, what exactly is robot? How does that word come from? That's a small tidbit which I find it interesting too. So the word robotics, it's derived from the word robot, which in turn it's actually a Slavic. They say it's a such a language word called robota, and robota means labor or work. That's what it means in that language, and that's where the word is derived from. And the first time the word robotics was ever used was by Isaac Asimov. Most of you might have heard about him. If not, I would strongly again recommend to read his books. He has got an awesome collection of stories and fictions and scientific articles written about robotics. And he is the one actually who has derived some laws for how exactly a robot should be designed or what should be a behavioral thing about a robot. And he first used that word robotics in his story called Liar, and that was published way back in 1941. So that would say that the initial spark or the initial start of the word robotics, and things are growing in a rapid speed from then on. So now let's go on to our next question. Again, a lot of people here. I know we have a mixed audience here right now. There are so many, people who are already know why they should really know. Why they should really learn robotics, or what is their purpose for that. But there may be someone who is interested in why I really should learn it. What's the purpose? I already know computer programming. We are doing a lot of stuff in computer, and I may not be doing anything on robots other than being a user and those kind of questions. But there are more reasons, why you should actually learn robotics. The first and the primary thing I would say is it's fun. Learn about robots. It's really fun. It's really cool actually. Even though whatever we learn about robotics, or whatever you learn about robotics on a course that you enroll for as a career or something as a serious note, you may not be able to build instantly or within the next few years, like kind of robots that you see on big screen, like on the movies like Transformers. You're not going to build anything like that instantly. That's not going to happen anytime soon. But then it would still give you, a concept, or it will give you the eagerness of like developing that concept we have, that something can be built similar to that one that we have seen on the big screens or in video games or in television. But then we also love, almost everyone I would say on this era would like to bridge the gap between the reality and the fiction. Now, what we see in fiction, it's always fascinating, and it's really fun to try something with our own hand to build something maybe closer to that one. So that could be one reason why we all should learn robotics, just because it's fun and it's extremely creative and interesting. Whoever feel like, see, whenever we talk about being creative, it's always related to soft skills or something like writing, drawing, painting. And I don't want to get into the debate of whether creating a robot is it really creative, but I can definitely tell you that there is a huge potential of being creative, and it's very interesting as well when you get into the field of robotics and start learning how to build a robot, start coding for it. You feel that you are contributing something to the scientific field that is very hot now, which is which is right on the technology currently, compared to any other fields, I would say. And then, which the third reason why we should learn robotics, which would be the primary reason for most of us, I would say, apart from the fun part and finding it very creative, is going to give, it is currently giving a lot of opportunities. It's just right on. And sometimes, the monetary value gives some, real idea about real hope for people who are trying to pursue a career in robotics, I would say. So, see, this is based on a real survey, and that's not some random numbers. The top robotics market is expected to grow from 76.6 billion last year to 176 billion, which is like 18% growth in the next 5 years. See, not considering about the current fact that the period that we live in, with all those calamities that's going around with um, uh, coronavirus and stuff, and anything that's affecting negatively to the world and to the world of opportunities. It still has so much of potential for robotics to to grow in that particular phase, which is going to be huge compared to many other markets or many other fields, I would say. To put on some charts, which gives a much better idea on what exactly I'm talking about when in numbers. Since being in analytics, charts and stuff are something I just work day in and day out. So this would be something I'd be interested to look at, and that may give you some more idea as well. As you could see from the few charts, it's tremendously growing, both monetary wise as well as usage wise. So the first chart that we see here, it's actually the number of robots that is being used industrial wise. This is mostly like industrial robots that are used in both service sector and as well as in manufacturing sector. You would have seen a lot of videos recently of how an Amazon warehouse is completely packed with service robots that moving around stuff and getting warehouse done. So those kind of robots, the usage is growing dramatically. And yeah, as you could see, even by this year end in 2021, it's going to be like nearly 4 million industrial robots are going to be used, and that is a global data, not just confined to US or any particular country. The second chart down, that is just specific to US, and highlight of US robotic process is given here just because it's not that US plays a major role or something like that, but it gives an overall idea about where the industry is going towards, since it has got a huge impact actually. So yeah, so based on the US process marketing, it's again, this is a monetary value. As you could see in 2016, it was just 0.12, but then it's just going enormously, right now, towards 2025, both robotic softwares and as well as in robotic service sectors. And the third one, the third pie chart, gives a glimpse on what kind of sectors are hugely using robots currently. These are again professional service robots that are currently in use. That is actually 2019 data, not even 2020. But as you could see, the major part of it, the 49 percentage of the robots that are currently being used in industry, goes into the logistics industry. So logistics includes any kind of transportation, even your electronic vehicles, or as I was mentioning, in Amazon warehouses, anything that involves logistics delivery. And you would be keep on hearing these days about drones being used for various purposes in logistics field. And very soon, it's pretty sure that in the next year or so, at least here in US, or maybe in few other European countries, and very soon in India too, drones would be the primary source for any kind of delivery here. Pizzas are being delivered already here, and Amazon packages are being delivered in using drones. So those all comes under logistics, and that is the major part that is currently being used for robotics. And other than that, there are like defense, professional cleaning, and various other fields that are using robotics as well. All right, so now let's get into why robotics is fun. And so this is something that came up yesterday. I was talking to the founder, ThickNess Learning Community, Kritik, and that was an excellent analogy that he mentioned. So most of the time when we talk about robots, people always used to think robots as something huge, or human sized, or larger than regular sized robots, like what we see in movies and video games and stuff. We all might be fascinated about the movie Endiran, and Terminator in Hollywood, which was like, okay, that is what a robot is all about, right? That's what we mostly think about. But yeah, by this time, most of us, thought process would have changed, but some may still think robots are so something like that's huge, more like a humanoid and kind of thing. But yeah, that is very far from truth. Robots at this age are of various sizes, and it's really hard to believe how much has been achieved already on when it comes to the size and the categories and the types of robots that are being made. As you could see in the picture, there are so much of variations in sizes, shapes, and designs, and that is what exactly I believe robotics, is fun. And that's what makes it fun. So even if you're not interested on any specific type, or like any specific industry oriented robot, there is always something for you to learn, to explore, and to design, or to learn more on robotics here. As you could see on the picture down left, there is a small robot which is on the size, which is less than a man's hand, which lies on his palm. And that's more maybe like a spy robot, or anything that can be used for various purposes actually. And even that is not the limit, or that is not the smallest size of a robot currently, as it's mentioned on the other picture. See, from the macro level, it has gone to micro level, and not just from micro, it is already in nano level. And not just nano, we are now moving towards an era that is going to be molecular. So yeah, there would be robots that is of that tiny to the molecular level itself. To give an example here, see the nano robots, there are so much of research and developments and R&Ds are going on currently for nano robots, where they say that those would be useful on medical fields, wherein there will be robots that are being either injected to you or being sent into your body, and that would actually fix a lot of medical issues, diseases, and stuff. To be precise, if there are cancer tissues on someone's body, the nano robots can be used to just clear up those tissues. And even if there is a block on our heart, and instead of having surgeries currently like open heart, nano robots would be the future wherein that would be sent into a body and that would clear the blockades from arteries in heart and stuff. So I'm just giving an highlight, and this is an overall view, and not exactly, we are going to talk a lot more about the usages of macro, micro, and nano, but that is what the path is all about. This is just to compare between what we see on TVs and movies, like and maybe in the movie and then we have seen something like the tiny robots coming up there that land somewhere even bigger than a macro robot, I would say. So there is so much potential over there, and that is so much fun as well to learn to know more about robots. All right, so now let's get more into the opportunities on robotics, right? What when it comes to, so let's assume that we are now getting into the question that is like, why we need to learn robotics and why I should think it as a career, and why should robotics be a career for me as an engineering graduate. There are so much of other branches as well, and why should I choose that? And this gives an overall idea about what are the different types, and again this is a general branch of classification. There are again so many different variants to this, but in general it can be classified as this. The jobs or the opportunities in robotics can be classified into these four: the robotic engineer, and then a robotic technician, a robotic operator, and then a robotic software engineer. So these all four might be at the first instance. This could be looking as very similar. You may ask, hey, what's the difference between a robotic engineer and technician? They both seems to be working on a robot, right? And what about the robotic operator? Is it more like just operating a robot? It's not that simplified. We will get into a little more detail into this in the coming up slides. And that may give you an overall idea about what these roles and opportunities is all about, and so that you can understand more on that one. So let's talk a little bit about robotic engineer. So a robotic engineer, he is the person who is actually responsible for creating and designing and the robotic system. So this is a person who is not going to actually do a lot of the hardware part of it, but he is going to do a lot of design part of it, and he may eventually end up with assembling and stuff as well, depending upon the industry that he is working on, and depending upon the complexity of the robot that he is going to work on. And he may also be responsible for designing the machines and the processes necessary to assemble the robots. So which means it's not that he's going to design just the robots. He may also be the person who would be designing the machines of that is actually going to produce the parts that will eventually turn up into a robot. So it all boils down to that role, who is called as a robotics engineer. And based upon the complexity of the robotic system, he may actually end up working on only a small handful projects throughout them, throughout his career, I would say. It's such a a huge potential opportunity for a person as a robotic engineer, that once a robot is being designed and it is being implemented on an industry, that itself is an achievement for someone's career, and that would last for him for his lifetime. And that's what that point actually tries to illustrate there. And once a device or once a robot is created, a robotic engineer's role will change to serving as a technical support as well, responding to fixed requests and change making changes to the system, and modifying the hardware design and stuff based upon the requirements. And that is again comes under the responsibility of a robotics engineer. And most of the time these engineers at these days, they use the CAD and then the CAM for manufacturing the design, and what kind of task that a robot needs to be performing, and so that would be its roles and responsibilities as a robotics engineer. We will move on to a robotic technician and how exactly this person is different from a robotics engineer. So even though he has a very similar duties with the robotics engineer, but he would be more focused on testing and repairing robotic systems, while helping the robotics engineer create and design them as well. So he will not be spending a lot of time onto designing a robotic system, but he will be doing a lot of testing, and he'll be fixing stuff once a design has been made or once a design has been implemented. So you would spend more time with the customers as well to ensure that the robots are working properly. And if, yeah, he's more like a liaison between, like, a bridge between the customers and the robotics engineers. So the customers, will be the ones who would be having the requirement, and the robotic designers would get that delivered. And this person, as a technician, would be a bridge to, to just connect between those two people, and then get the things delivered. And then he will be having extensive knowledge on troubleshooting all those sensors and programmable controllers and circuits and stuff. So he would be the go-to guy if something goes wrong on an industry once a robotic system has been implemented. And then this role also includes on training robots using artificial intelligence, using various techniques, and perform complex tasks. And it involves, again, based upon the industry that he works on, but it all boils down to his role as a robotics technician. Let's move on to the next one. As a robotics operator, so this is, again, a role that doesn't involve a lot of designing or a lot of a technical expertise in fixing or troubleshooting stuff. So this is more like, someone who actually operates a robot. It's not that, in current day scenario on an industry, even though there are a lot of machineries being used, and there are so much of mechanical operators handling those machines, this is a little different than what exactly being done. So see, it's that somebody, even though we say that robotics is more like an automated one, it's automated. There is no any human intervention, and there is always talk that whenever I bring up the talk about robotics, people say that, hey, that's going to take out so much of jobs out of the market, because a lot of human efforts are being reduced now because it's all automated. And a lot of transitions towards automation is not a good thing for humankind itself. That's what one kind of ideology is. But I slightly differ to that point of view. Actually, there are so much of articles which really, I would say that support these automations, just because all the hard efforts, all the hard work that the humankind needs to put in now can be automated with robots, which really allows the humans to explore more on it's something that's not very hard on human energy, and spend something more on a productive side. That's a altogether different topic. But when we talk about robotics operator roles and responsibilities, even though robots are automated ones, they still need some kind of human intervention at any stages. And there'll be a person who would really need to operate, or just make sure things are working as it should be. And that is what a robotics operator would do. So it would involve, where he will also be the person who would set up, and then he will maintain a machine. And it's again his duties to enter the pre-programmed instructions, or to change it based upon, say, for example, if it is a manufacturing robot, he would be the person who would actually input the feeds on what kind of dimensions of a product that is being manufactured, or what exact duties that the robot needs to perform. That is something he would be taking care. And these setup procedures ensure that the robot produces the products or the services to exact specification that is being expected from it. The operator may also inspect the output from the machine to ensure quality, and make adjustments during a production run if necessary. So yeah, that is what a robotics operator does. I believe this gives at least a overall idea about the differences on these three roles between a robotics engineer, a robotics technician, and then a robotics operator. So these are all potential opportunities. Even though we talk robotics as a single entity, these are the branches that we can focus on. And based upon once a personal interest, like someone might be very interested on being a technician, they may not be pretty much interested on being just an operator. Some might be really interested on being an operator to be with the robots, and may not be very much interested in coding and stuff. So there is room for everyone. That is the point that I'm trying to insist here. There is so much of options available there within this the general term called robotics. And then the last but definitely not the least, the robotic software engineer. This person plays a very key role in any kind of robotics the division, I would say. So because this is the person who actually writes the software, the heart of any robot, or what exactly a robot needs to do, that will be handled by the code that the software engineers write. So the robot's computer system is pivotal, and it's essentially provides the brain behind the operation. It includes working on an embedded system that controls automated equipment that he may build. New softwares might be built or test, and again, the whole cycle of a software program comes into play here as well. You just write a software, you test it, you improve it, you bug fix that, and those kind of stuff. But it's all comes well, on this on this direction. It's going to be completely onto robotics here. There are again not just like regular softwares or writing regular codes. There are dedicated operating systems just for robots as well. So it's called ROS. It's a robotic operating system. So there's again so much going on the software engineering part for robotics. So yeah, we all know that basically when a human tells when a human wants a robot to do something, it could either be verbally now, using voice recognition and keystrokes and stuff. It's based upon the code or the software engineer's program that it's going to be determined how accurately the robot is going to perform such tasks. So when it comes to requirement for being a software engineer, again, there are tons of coding languages, but again, the core boils down to something like C++ or Java. And even if it's embedded software, it mostly relies on Linux. So that is is what exactly is a career in robotics is all about. So I hope you get some idea, or maybe some understanding, and might find it useful so far with those two questions that we have looked upon. What exactly is robotics, and why exactly we should learn, and what are the opportunities there. Now let's move on to our third part, the third question of the session, which is like how to build a career in robotics. So now what is robotics to some extent, maybe with that just one of single paragraph of definition that we have seen. Do you have some idea? You might be already knowing a lot more than what has been said so far, and we know what is robotics and the stuff, and why we need to build a career. What are the potential opportunities, and how the market is growing is what we have seen so far. And so if you're really interested now, hey, I want to really build a career in robotics, how exactly do I do that? And again, there is so many paths to that destination. And what I'm trying to capture here is again an overview, or a small a torch, or a light that might help you walk through the path, and that might give you might give you more idea. Maybe you might find it more interesting on which path that you would like to choose. See, before we really think about as a career, most of the time I would suggest to have robotics as it's more like an hobby, right? Whatever hobby that you do, you just go for cycling, you do fishing, you read books, and it's robotics is also a kind of hobby that you start with, and you find it fascinating. You find it which exact field, or what kind of robot is what you are interested in, and then you navigate through that, you strengthen your skills on that, and then you actively get involved on more of the activities and competitions, and with the robotic clubs and stuff. And then you make it as your career, and then you just get into the industry and stuff, right? So that's what it all boils down to. So you, as a hobby, you would just start with writing some simple programs. You build your own simple robots using kits that are available these days, and then you find that it's joyful and it's really fun. And once you have that kind of fun experience, and you really want to pursue more, the best way to develop or to learn robotics is to improve your proficiency in computer science, coding, physics, and importantly linear algebra as well. And this is most of the time for someone who is in college right now, who is already in doing computer science, engineering, or electronics. They would have done some of it or most of it already, and they may have it as a passion as well. That is fantastic to get to have robotics as a career. Even if it's not, there is still a lot of other ways to get there. Yeah, so for someone like who is not in engineering branch currently, who is in arts, or who is doing maybe there's of any of their levels of education, they could still get there, and get their interest there. What I'm trying to say here is that all you need is the passion, and if you really find robotics as fun, there is a way for you to proceed through these steps and have it as a career, and no matter what age and what level of education you have currently. Yeah, as I was mentioning, once you got enough proficiency with coding and physics and stuff, you can take more robotic classes, and then get into more clubs and competitions, and then you can strengthen your skills over the time. And once you have that, there is always a huge potential for you to get into and make robotics as your career. So the reasons why of these four things are being insisted here, why do I need to practice coding, and what is linear algebra and physics as a background, and why computer science? Even though these four things might seems like, okay, hey, this is something like a robotic software engineer needs it, why I'm interested more onto a robotic engineer or a robotic technician, why do I need to know these things? But I think that kind of questions are kind of immaterial these days. We all know that coding is something that is becoming an essential skill for any branch of education now. And when it comes to robotics in specific, where it's again the foundational element of no matter whichever job role that you're planning to take it. You need to know those basic stuff like using variables and functions and coding skills. And when it comes to hard code programming, again, currently the popular ones are Python and C++. C++, we all know that that is the building block for any kind of computer software these days. Even still, even though we have a lot of other programming languages, and the technologies keep on growing tremendously on that area. And I have given some suggestions here. There are a lot more sites. You all would find tons and tons of websites to learn these languages. But to start with, as a beginner, for someone who has never done any kind of coding, who has no idea about coding, and who has never heard the term Python as a programming language, these three websites I would strongly suggest to go through that, and then slowly start exploring, especially W3 schools and learn Python. These all these sites are free of cost. There is no charge in learning on this one. All you need is the interest to do some programming on these languages. So give it a try. W3 schools and stuff. Not just Python, and there are so much of other languages and other coding tutorials available on those sites, which you would definitely find it useful, I believe. So linear algebra again, see, we mathematics again is a key to this particular field, I would say, especially robotics. And it's essential for both programming and also programming a robot, and also tweaking its code. And then again, it's a whole together a whole different topic to discuss about the importance of linear algebra. But at this point, just understand that this is something that is key. So you need to have, or it's better to have a greater proficiency on this one at your high school level or even at your college level. And again, even if you haven't learned a lot so far, and you're already in college, and they, hey, like, hey, I could have done that better, but I missed it. But again, there is no worries. There are, when it comes to resources at this age, there is no point in, feeling like missing out or not able to learn something. There is so much of tons of resources available online. And once again, a few resources here I would suggest is the Khan Academy, which is again a free website that gives so much of resources to learn more on mathematics, not just linear algebra, on any topics of mathematics, which is again key to any technology related careers. And again, there is something like Open University, which is again, it's open and it's free, where you can learn physics, mathematics, and any kind of computer courses as well. So just give it a shot, give it a try, and then see. Maybe you can evaluate yourself on where you stand, and you can pick something new that you want to learn if you are really interested on pursuing a career in robotics. And again, these are all I'm just iterating just to make sure that you don't need, there's nothing need to be worried about if you haven't done anything so far. There is so much to be done, and there is so many ways to do these things going ahead. All right. So now you have it as a hobby. You take part in a lot of club activities, like taking part in robotic competitions, and you build your own robots. You find it fascinating. You are so much interested. And then how exactly you transition that hobby into a career, right? So, and this is again a very generic view, and there is so much to be discussed on that. But this will give you some idea about that. Like what we have the traditional mechanical, electrical, and electronic engineering currently. There are new branches coming up throughout the country, not just in any one country like US or in India, and specifically in India. These new branches are growing very fast. That's what I'm hearing, and I'm reading a lot more on that one. Mechatronics engineering is something that is strongly suggested for someone who is who want to get into robotics as an engineer. And then BTech in automation and robotics, and then maybe a BE in advanced robotics. See, these courses may not be available currently on all the colleges, but it's very sure down the lane, and then the coming up years, almost every college would be, every engineering college would be offering these courses, and this should be available for most of the students. And again, if you need to be a robotics engineer primarily, for you would be having a bachelor's degree in robotics. And as doing the initial start of the session, I was mentioning, it's not confined to any one specific branch of engineering. It needs like a mechanical, electrical, and electronics, and many other. So even if you are persuading, or if you are currently in like a mechanical or any other branch of engineering, that is still not a wrong decision, or it's still not a not a wrong path to take towards robotics. You can still get it over there by doing additional courses apart from colleges, or doing a master's that is more related to robotic engineering. And most of the time, the general training would be on pneumatics and hydraulics and control systems. These are all the specifications of the engineering divisions that one has to learn, and strengthen their skills uh, to be becoming a robotic engineer or pursuing a career in robotics. As I was mentioning, not all the universities offer these degrees these days, since it really heavily relies on experience of several engineering disciplines. You can just do any other discipline as well, and industries are still are interested on candidates who have not just done robotic engineering branch, but any other engineering branch, but have got the skills that is necessary to becoming a robotic engineer. And for any senior level or upper level positions within the industry, a master's or a doctorate degree would be needed on robotic engineering. So that is for having robotics as a career, and to persuade it as a lifetime career opportunity. But then I believe there will be more audience to this session who are like, okay, hey, I have a kid, or maybe I'm a beginner, I have no idea about what exactly robotics is all about. So do I still have a chance? Where do I start? And those kind of questions. And again, this is a overall view I'm trying to answer, or trying to uh, give that spark of knowing something about robotics, and then try to experiment it, or just give it a shot on seeing, okay, hey, maybe this is interesting. And those kind of interest for kids who are in that maybe middle school or even in elementary school level, these are certain kits that are currently available in the market, which are really cool to try and experiment and learn more on robotics. So there's something called Arduino. This is again more onto circuits and electronics and building. That is what we see is a miniature motherboard, I would say, like that gives you, and that has got a huge potential of building, you customize the electronic devices, not just robots, I would say, to learn and understand the concepts of circuits and electronics, and how things work on an VLSI level. And then and these days the technology is so much onto something called IoT, Internet of Things, and those things can be explored and learned using these smaller devices, or there is the smaller kits that would help understand the concepts of electronics and circuit systems and embedded systems. So Arduino is something I would strongly suggest for someone who is more onto learning on the basics of electronics and the circuits. And then the most popular one currently in the market, I would say, and that one is pretty expensive too. It's the Lego Mindstorm EV3. So this is nothing but we all as kids might have come across the Lego blocks, which we would like to build, like buildings and the cars and stuff as a as a building block kind of thing. But then this kit from Lego is it's amazing, I would say. It has got all the basic stuff that we need to becoming a robotic engineer, I would say, the basics of it. And definitely this would excite any kid who is interested on robotics. As you could see, they come up with a pre-provided set of sensors and a central a block that's they we call it as a brick or a block, which is more like a CPU for the robot that you're building. And again, this one has got huge potential of learning and then exploring on what a robot can do. And this kit comes with a lot of accessories and the sensors and cables that is needed. It comes up with three motors which can be combined to create your own robot that actually moves, or that that does stuff. As a toy level, even though I say toy level, there are wonderful projects being done using Lego EV3. That is something you can definitely consider, or try exploring it. It is, again, as I said, it's a bit expensive, but it's worth trying it, and then exploring and to start up as a spark for a kid to learn more onto that one. So that is one thing. And again, another one very similar, but maybe in a more fun way is this UBTech, the Jimu robot kit. Again, that is not as expensive as the Lego EV3, but still it's really a pretty good one for kids to build robots on their own. So another fun part of this is that apart from simply building robots, what's the point in just assembling stuff and then creating a robot? You need to customize that. You need to code that robot that as well, right? And these two kits, the Lego Mindstorm EV3 as well as the UBTech, they comes with their the proprietary software platform where the kids can write, not just kids, again, for any beginners even can learn coding. They can write the code to make their robot perform the task that they want to. So they can just make them move, perform tasks, do whatever they were planning to do. And that kind of opportunity is there, so that the kids and the beginners they will be able to learn programming concepts. They can experiment their program, they can write their own code, and then apply that code to this robot that they built with the accessories they got. And then and they can just enjoy watching the robot do the task that they have written coding for. So it gives a complete life cycle of how to start building a robot, write codes, and implementing it, and then see the robot works, or and just to play with it for fun. So these two are excellent resources I would suggest. And then the third one that we see on on the bottom left is something called as a Z-bot, that is built by someone who is in our own state in Tamil Nadu. So yeah, for those who are not aware of this, there is a club in Chennai that's called Tamil Robotics Club. I would strongly suggest to visit their website. They are doing an incredible job so far. They are just more like a startup, I would say. They are just budding engineers over there, and there are so much of experts involved in that club as well. That is it's something like we as someone who is interested in robotics, supporting those guys locally instead of going for the bigger MNC products like Lego and Ubitech. Definitely, they provide the equal, I would say, the knowledge and proficiency of these bigger players as well. So give up the give it a shot. Just visit their website and see if you could try out with their products. They're launching a product very soon, I guess, locally from Tamil Nadu. And then there is another part, is something called as scratch programming, and that is again completely for beginners, or I would say this is more for elementary kids who has got no idea about programming at all, and they want, if they say, if a kid who is of age like say between 7 and 10 or 7 and 12, who is for the first time writing a program, to make them learn in a more fun way, to make them more learn in a joyful way. There is something called it scratch programming, and that has been designed by MIT, the Massachusetts Institute of Technology here in US, and that is a pretty cool one. I would say, I would strongly say that is again a free tool. It's free to sign up, and then anyone can sign up and then start learning the basics of programming. That is something called as a block-based programming. The kids don't really write coding. They don't really type in and then code. They just drag and drop stuff to make things move, like do some smaller animations, make an animated character move left, move right, do tasks in a more fun way. So that gives a fundamental idea about what exactly programming is all about, and how to do a simple animation or a simple game, or to a higher level to see how a robot can be performed over there. And that will gradually take them towards the path of doing robotics, I would say. So these are some robotic kids choices for kids and someone who want to try to learn into robotics. And just to mention that the scratch programming is something that we teach here in Sparkle Computer Education. We currently take online classes for kids who are interested in learning scratch. And if anyone is interested, just feel free to drop in a mail at contact at sparkle.com, or you can reach us through ThickNess Learning Community as well. The last one I have is some of the links that I found very useful. This will be shared through the presentation and through Thickness Learning Community as well. So I would really suggest going through these links. That would give more than what we see today in the session. On understanding the fundamentals of robotics, and again, that gives us so much of other information. And one thing, when I was just gathering information for this presentation, one thing I found very useful is that there is an YouTube channel for IIT Kharagpur, and there is a professor who has given a series of videos for introduction to robots and robotics. That is the link over there. You can simply just search for their channel, IIT Kharagpur, July 2018 as well. That those videos are really good. He has given a complete overview and walk in lesson by lesson on what is robots and what exactly is robotics is all about. So just check it out, and that is all I have for today's session. I hope you find it useful. If you have any questions, just type it, or we can maybe go through that one as well. But again, thank you all for joining today, and it's nice to be here and sharing what we have gained so far about robotics. With that, I'll conclude the session, and once again, thanks to Thickness Learning Community. I'll switch it over back to Kritik, the founder.
Yes, it was really a great session. Hope our audience have got more knowledge from out of it. And we have few questions that has been asked by our participants.
Sure.
And so first question goes like, so it has been asked by Arjit Das. Can
Okay.
anyone explain about tiny ML?
Can you please repeat?
Can anyone explain about tiny ML,
Okay.
machine learning, tiny machine
Machine learning.
learning?
Yeah. Well, okay. To be frank, I don't have much idea about tiny ML at this point. But maybe I can check on and then send out those details. Yeah, at this point, I don't have an answer for that.
Yeah, so Mr. Ajitas, you can Google it or else come back later to thickness www.thicknesslg.com to find the details of what you have asked from our speaker in the latest resource bar. And moving on to the next question, we have another question from Arjit Das. What are the probable example of running applications programmed using Java in robotics? The usage of Java in robotics.
Well, see, when it comes to programming languages that are pertaining to robotics, you know, as we see, even though the most popular ones currently are Python and C++, Java has got so much of applications being running currently on robotics that are being built upon as well. So, see, for example, the very simple example I can give is that when it comes to medical fields here, as I'm closely related to some of the medical applications here, there is so much of coding and then applications being built upon in Java just because of the strong security, if features that Java provides, and that is being one factor which is being completely covered upon for robotics as well. So any application basically that is being developed in Java, and if that application can be tweaked or being persuaded towards a robotic application, that is definitely a go. And there is I'm pretty sure there is a lot of things going on for robotic applications using Java language as well.
Yes, so that's the end of our question. So over to Dr. Shanti.
Really lot of inputs.
Sure.
Yeah. Ladies and gentlemen, yeah, very warm and pleasant good evening to all. At the outset, it gives me an immense pleasure to propose the vote of thanks for this wonderful occasion, an international webinar on robotics and its opportunities. I would like to thank today's resource person, Mr. Anand, co-founder, Sparkle Computer Education, Rochester, USA, who honored this program despite his busy schedule, has found time to grace us with this wonderful lecture. Thank you very much, Mr. Anand.
Thank you, Shanti madam.
I am also very grateful to Thickness Learning Community, young and dynamic founder and CEO, Mr. Kritik Raja, and members of the TLC for their encouragement, backing, arrangement, valuable contribution, and wonderful support to make this webinar grand success. Last but not least, I would like to thank all Thickness Learning Community beloved participants from different positions for showing their interest in this webinar, for making this event as a resounding success. Thickness Learning Community upcoming webinars are career opportunities in embedded system, opportunities in data sciences, Python programming in future, etc. Once again, I thank one and all present here. Have a wonderful day ahead. Have a nice weekend. Thank you very much.
Thank you again, everyone.